Underneath Antarctica's ice, there's a deep, dark secret. Today, we're going to melt all that ice to find out how it would transform Earth. What mysteries lie buried deep under its thick, frozen surface? As the ice melts and sea levels rise, what would happen to our coastal cities? And why might this lead to some unexpected diseases? This is What If, and here's what would happen if all Antarctica's ice suddenly melted. Welcome to Antarctica, the continent that encircles the South Pole. It's 40% bigger than Europe and full of ice. Here you'll find seals, whales, penguins, and the odd scientists doing some research. And on this continent, you'll find an ice chunk the size of Florida. Welcome to the 120-kilometer wide Thwaites Glacier. Its more scary nickname is the Doomsday Glacier. When it melts, there will be a catastrophic rise in sea levels all over the world. Now, this Doomsday Glacier is melting incredibly fast. It sheds 50 billion tons of ice into the ocean every year, and it accounts for 4% of the 9 inches of sea level rise that's happened so far. Some scientists are predicting that the whole thing might melt in decades rather than centuries. But we don't even have a few decades to hang around, let alone centuries. So I'm going to show you what happens if it melts a whole lot sooner, in seconds. In just a few seconds, Thwaites has melted and flowed into the Southern Ocean that surrounds it, and from there into the Indian Ocean, the Atlantic, and the Pacific. Sea levels rise by 60 centimeters around the world. The streets of San Francisco are getting flooded. Miami and New Orleans are also rushed with water. But what's going on? Why did this glacier crack and break away from the rest? Well, there's something going on underneath. Beneath Thwaites is a massive river flowing fast. Melted ice from the iceberg is feeding it. This is happening thanks to geothermal energy from the Earth's molten interior. The melting process starts off slow, but eventually huge chunks of ice break off. This starts a chain reaction, causing more and more ice to break off and melt. And there's more to it than just one river. A whole world of mysteries lies beneath the ice of Antarctica. But before I take you to that fascinating underworld, I want to tell you about why Antarctica is so important. It's an ice sheet covering an area of 14 million square kilometers, with an average thickness of over 2 kilometers. Just for comparison, that's 1.5 times the area of the United States. That is a staggering amount of ice, 25 million cubic kilometers of it. It's 90% of all the ice on the globe, and locked up in that ice is 60% of Earth's fresh water. Now, unlike the Arctic, where the ice is floating on water, there's land beneath the ice in Antarctica. You don't think about it because 98% of the land is covered with ice. And that's not all. 1.5 million square kilometers of ocean is also hiding underneath this ice. And when all this ice melts in a few minutes, sea levels are going to rise an astounding 70 meters. It'll take more than just their cutting-edge technology to fight what's hidden beneath the ice. Let's take a look at the bizarre creatures waiting for us inside this frozen landscape. As you explore this uncharted territory, you'll get a peek at the ocean floor, and just above you, you'll see the underside of the ice. Here, you'll find a type of marine life called anemones. These tiny little creatures are burrowed into the underside of the ice. You'll also find some other small fish and crustaceans. The anemones you find are going to be very different from what you'd find normally in the ocean. They're a new species with an unusual trait. See, anemones usually stay rooted to a single spot, kind of like a plant, but these Antarctic anemones wriggle about in the water. Scientists are still figuring out where they're trying to go. Okay, almost nothing grows in that cold darkness, right? So, what are these creatures eating, and how are they surviving? Well, it's probably little bits of plankton and poop ferried in by ocean currents, but they're also eating something that's super weird and kind of gross. It's the ocean equivalent of rotting food in the back of your fridge. These creatures are eating millions-of-year-old rotting skeletons, bodies, and ancient bacteria that were around when Earth was much warmer. Ooh, watch out! A few more massive glaciers are about to break off. As the neighboring glaciers to Thwaites separate and melt, more water pours into the oceans. Worldwide, sea levels rise another 2.5 meters. Cities on the east coast of the United States are covered in water. Boston, New York, Miami, millions of people are affected. Even as cities are getting submerged, something bizarre would be going on right off the coast of Antarctica. Close by, the sea level would actually be falling as all this ice was melting, while the sea level further away would be rising. Now, why would this strange event be happening? Well, remember, the Antarctic ice sheet is enormous. It weighs a mind-boggling 24 billion megatons. So it exerts its own gravitational pull on the surrounding waters, which raises the sea level nearby. But when the ice melts, the power of that gravity is gone, so sea levels nearby fall, just as they're getting higher elsewhere. Over in the east end of Antarctica, the Denmark and Scots glaciers have melted. This adds another 1.5 meters of water to our oceans. Now, at a 4-meter rise, the United States is now losing national monuments. The Jefferson Memorial is underwater, Fenway Park is submerged, major coastal cities around the world are also flooded. Shanghai, Lagos, Mumbai, Jakarta, ports are flooded and destroyed. All that salty water is flowing into farmland and destroying our crops. Even worse, underground aquifers that give us drinking water are now contaminated with saline spilling over from the ocean. What's scarier is that the contamination runs deeper than just salt. The Antarctic ice carries bacteria that have traits that are dangerous to human beings. Some of these bacteria cause infections, and they're linked to diseases like cystic fibrosis. But it gets worse. They have an even more deadly superpower. They're resistant to the antibiotics we use to treat diseases today. If they exchange parts of their genes with the bacteria of our world, the resistance to drugs will only grow and spread to even more bacteria. At this point, we humans would be toast. We'd no longer be able to fight off bacterial infections. Not good if we're drinking contaminated water. But like any Hollywood villain, these bacteria also have a good side. They can help us create new and better antibiotics. They can help clean up toxic waste sites and maybe even be part of a new biodegradable alternative to plastics. As more and more ice breaks off and melts, other ecological systems are getting thrown out of whack. For one, the melting ice is changing the way ocean currents flow. Before all this ice melted, the water in the oceans moved around in a very particular way. Dense, salty water sank to the bottom of the ocean floor, pushing the less dense water up to the surface. Through this movement, the water acted like a giant conveyor belt, transporting heat and nutrients from one place to another. This is a key factor for the survival of marine life. Now, with fresh water from melting glaciers entering the picture, the water at the ocean's surface becomes less salty and dense and doesn't sink down as far. It's like our ocean conveyor belt has been jammed up. It's no longer able to move heat around from one place to another. Scientists warn that the melting of the Arctic will mess with the warm Gulf Stream. They're still figuring out how an Antarctic ice melt will change our climate. Under some circumstances, for instance, if icebergs broke from the Antarctic and melted further away in the Atlantic, The changes in ocean circulation could bring on an ice age. But if the melting primarily caused sea levels to rise, well, we'd probably just end up with a warmer Earth. And it's not just heat patterns that we need to worry about. Breaking the oceanic conveyor belt means problems with the movement of nutrients from the ocean floor to the surface. These nutrients are important for the growth of phytoplankton, tiny algae at the bottom of the ocean food chain. They may seem small and insignificant, but they're the bedrock of life in the ocean. They provide essential nutrients to marine life. But not all phytoplankton would suffer the same fate. For the phytoplankton around Antarctica's waters, the melting ice would provide iron and give them something rich to feast on. In fact, this event might lead to a temporary massive algae bloom as the waters are flooded with nutrients that were previously buried in the ice. The growth of the phytoplankton might be a good thing because at least they'll absorb a little carbon dioxide. The Earth will need that. Why? Well, because all this ice melting is going to make the planet a lot hotter for several reasons. First, ice helps keep Earth cooler through its super reflective surface. It's very effective at bouncing sunlight away from Earth's surface, which helps keep things cool. But once it's melted, that's a different story. With glaciers melting and the water warming, the activity of microscopic fungi in the water is also picking up. Just like dead leaves decompose in forests, microscopic fungi act on dead matter in the oceans, decomposing it and releasing carbon dioxide. Warmer oceans mean more dead matter gets decomposed, leading to more carbon dioxide being released. Now, on top of this, the melting glaciers create a layer of fresh water on top of the salty ocean water. This causes the oceans to be less efficient at removing carbon dioxide from the air, again, adding to the warming. And now, the rest of Antarctica is breaking up into humongous chunks and melting rapidly. Water from the melting ice pouring into the oceans. As the ice melts, something amazing is revealed. A natural wonder that's been hidden for millions of years. An enormous canyon system, 100 kilometers longer than the Grand Canyon. It's the deepest canyon on Earth, running 3.5 kilometers below sea level and stretching all the way from the interior to the coast. And now you can also see the 15-million-year-old Lake Vostok, the 6th largest lake in the world by volume. And good news, with all the ice melted, you can picnic there. If you're still in the mood to picnic after everything the Earth is going through. Plus, you might want to stay away from the microorganisms living in the waters of Lake Vostok. They've been evolving there, isolated from the influences of our world for 15 million years. Who knows what they could do to your body? But there's no time to admire the canyon or peer at Lake Vostok because sea levels are rising, higher and faster than before. You're witnessing the last and most dangerous stretch. Every last chunk of ice is melted. Sea levels have risen over 70 meters. This rapid rise has caught people by surprise. 40% of the world's population, over 3 billion people, live near a coastline. And the vast majority of them have drowned as Antarctica's ice has melted in a matter of minutes. The entire Atlantic seaboard, including huge chunks of the United States, is gone, submerged underwater. People in skyscrapers as high as 23 stories are forced to race to the rooftop in a desperate bid to survive. Parts of California are transformed into bunches of little islands surrounded by water, and other parts of the state are completely gone. London, Paris, Venice, and every major coastal city we know and love is underwater. Millions of people are displaced, injured, or potentially dying from this catastrophic event. Anyone smart enough to jump in their car and flee inland as the water first started pouring onto land may have escaped with their lives if they could get to higher ground, but those are only a lucky few. Governments are in a panic, deploying emergency operations. They know that almost everyone on the coast is drowned, but maybe there's a way to rescue desperate people on top of skyscrapers. But with so many people affected, are there enough helicopters to even rescue these people? Boats would be needed. How will governments be able to replace all the destroyed infrastructure? More importantly, what will we do about the sudden lack of fresh water? With our fresh water mixed with salt water, humans now have a serious lack of drinking water. Suddenly, the land in the interior has become the hottest property. People living in the US Midwest are super happy they were never ever part of the wealthy coastal elite. Denver, Minneapolis, and Las Vegas are looking more attractive than ever before. Now, nations in the southern part of the globe are hit even harder. All of Bangladesh, with a population of 160 million people, is underwater. Geopolitical tensions rise as countries are looking for aid, but since so many places are hit, help is hard to come by. Now that all of the ice is gone, there's still another thing that has to melt: the permafrost. This is the soil that's been frozen at the poles for more than 40,000 years. As it thaws, it releases the carbon dioxide and methane that are trapped underneath it, causing the Earth to warm more and melt even more of the permafrost. As the permafrost thaws, it's as if someone popped a frozen dinner into the microwave. Tiny organisms start to munch on the freshly thawed ancient organic matter. As they do this, they fart out carbon dioxide and methane, which causes global temperatures to rise even more. Great, now we're breathing in microorganism farts and it's getting hotter. Worst scenario ever. Oh, but it can get even worse. In the midst of all this, it's possible that DNA viruses in the permafrost will thaw and kick off a global pandemic. Creating a vaccine in the midst of this catastrophe would be a challenge like never before. Plus, it's hot. Earth is 5 to 10 degrees Celsius warmer. The heat is what's driven the entire ice sheet to melt, but now these changes are making it even hotter. With the average temperature on Earth now almost 27 degrees Celsius, a mass migration of people begins. The most popular spots? Well, Canada, Alaska, and the newly unveiled Arctic and Antarctic regions. These are the new tropical paradises. 34 million years ago, Antarctica was a temperate rainforest like New Zealand. Maybe that's going to happen all over again. Palm trees on the Antarctic coast and alligators swimming in the warm South Ocean. Let's step back 2 billion years back into Earth's evolution. A time full of life, but also mass extinction. An invisible killer was on the loose, ready to change the course of history. This was a time on Earth that had direct impact on what the world's like today. The animals that inhabit it, the food that we eat, and the air we breathe. Would you be able to survive in this new environment? And how did almost all life come to an end during this time? Time to go back 2 billion years ago. Welcome to Earth 2 billion years ago. You're landing at a time when Earth is about halfway to its current age. Now, as you make your descent towards this prehistoric Earth, you'll see blobs of land and maybe some chunks of ice separated by water. These land masses look nothing like our continents today, but that's gonna change soon. As your time machine touches down, it's a bleak and rocky landscape. There are no plants, no trees, no vegetation at all. No signs of any animals either. This was a time before complex multicellular life. The only living things on Earth were microorganisms. Yeah, it might sound a little dull, but at least there are no predators you need to worry about. I hope. Before you step out on the ground, you better put on your suit that's fitted with oxygen tanks, because while there is oxygen in the air, there isn't enough for you to breathe comfortably. It's less than 10% of today's oxygen levels. When Earth was first formed, there was only carbon dioxide, methane, and water vapor in the air. But more on that in a minute. As you step out, you look into the water surrounding you. It's completely still and there are no fish swimming in it, but it's filled with a ton of green, slimy stuff. What you're looking at is a whole lot of cyanobacteria, one of the most important bacteria ever to live on Earth. Cyanobacteria are responsible for the air we breathe, but they were also responsible for the most massive extinction event of all time. Flashback about 500 million years. Let's talk about bacteria. Just like today, it was causing some big issues back then, too. Let's travel back to Earth about 2.5 billion years ago to see what I mean. Like the calm before the mass extinction event, everything looks great on Earth. Our young sun is a bit dimmer, even a little bit cooler, but temperatures on Earth are balmy, around 21 degrees Celsius. There's plenty of liquid water, but no ice. The carbon dioxide and methane in the atmosphere are driving a greenhouse effect. The only life that's around is in the water, and again, I'm not talking about fish. It's all single-celled organisms like bacteria, which were living in very different circumstances, like the zero-oxygen environment you're standing in right now. But this water isn't only filled with boring bacteria, it's now filled with cyanobacteria. This bacteria evolved with a special trait, the ability to use water as a fuel to photosynthesize. And with this trait, it was able to produce oxygen. The cyanobacteria began to change the chemistry of Earth's atmosphere. As bigger and bigger colonies of cyanobacteria photosynthesized, they produced more and more oxygen. Now, this didn't result in much at the start, as much of the oxygen being produced would react with minerals and get removed from the environment. But fast forward a few 100 million years, and things start to change drastically. Now, so much oxygen is being produced that it can't be removed fast enough. It oxygenates the water, it escapes into the air, it reacts with methane and displaces it from the atmosphere. Earth's atmosphere is filling up with oxygen and becoming breathable. But don't take off that mask just yet. The oxygen level is still only 20 to 40% of what it is today, maybe even lower, but this level is obviously much higher than the near zero level Earth had before. So, how do the other bacteria react to this new level of oxygen? Well, you can't see it happening because they're microscopic, but they're dying off in huge numbers. This is the Great Oxidation Event, also known as the biggest extinction event in Earth's history. The oxygen being created turned out to be pure poison for other bacteria, killing off 99% of all life on Earth. And this isn't the only catastrophic event happening. This massive amount of oxygen in the atmosphere is about to have a big impact on something else. The cyanobacteria is creating oxygen, but it's also wiping out two greenhouse gases, carbon dioxide and methane. These two gases played a key role in the evolution of Earth up until now. They helped trap the sun's energy, keeping the planet warm. With both of these elements being removed and oxygen taking their place, it's starting to get very, very cold. Over hundreds of millions of years, you'd see massive changes in the landscape. The oceans are freezing. Sheets of ice are covering Earth. Brown and rocky land is now turning snow white. One of the earliest ice ages has begun. This is the start of the Huronian glaciation. It'll last about 200 million years. Throughout this time, you'll see Earth go through 3 glaciations. No part of the planet is spared. The continents, the poles, even at sea level. It's all ice all the time. Now, all life on Earth has already taken a severe beating, and these chilly conditions aren't doing much to help. Neither the oxygen nor the deep freeze are doing any good for the survival of our older microbes. But somehow, a small sliver of life, just around 1% of the living, persists over these 200 million years. No, sorry you can't see them, they're still microscopic and living in rare parts of the Earth. They're just hanging on, waiting for the ice to thaw. Wow, look at you, time traveling everywhere. You're quite the explorer. If you want to explore even more, well, you should check out the What If Explorers Club on Patreon. There you'll find ad-free videos, get a chance to contribute story ideas like this one, and more. But our Explorers Club is in the present day, and right now, you're 2 billion years in the past, at a pretty significant turning point in history. A whole slew of exciting things are about to happen that will transform the face of Earth, both physically and biologically. Volcanoes are erupting, the ice is melting, a new continent is forming, and life is making a comeback. 3 different natural and geological processes started, beginning a transformation and ending the ice-covered Earth. Let's go through them. The sun is a little bit warmer now than when we flashed back the extra 500 million years, but maybe you noticed the sun is also looking a little bit brighter. Well, this is because the sun's luminosity increases at the rate of about 1 degree Celsius every 100 million years. So now the sun is 5 degrees warmer. But this warmer sun by itself is not what melted the ice sheets. A second natural phenomenon is now playing a role. It's typically known for causing mass destruction and extinctions, but at this point in history, it's shaping the continents and saving the Earth. I'm talking about volcanoes. Although Earth was just covered with significant amounts of ice, under the crust, it remains hot and molten. Plate tectonics are starting to change things deep below the surface. A giant surge of volcanic activity is happening. Powerful whirlpool currents of lava deep in the mantle can no longer be suppressed. Magma is swelling up under the Earth and breaking through in a series of volcanic eruptions. These explosive conditions will continue for another 300 million years. The small separate land masses that you saw as your time machine descended are being pulled together by this volcanic activity to form the first supercontinent, Nuna. Fast forward to today and you'd be standing in Colombia. The volcanoes are also causing a remarkable transformation of Earth's atmosphere. This will affect the climate, making it much warmer. Now, this change might seem catastrophic at first, but it's going to give life on Earth another chance. That's because these volcanic eruptions are spewing water vapor and carbon dioxide into the air, and there's no microbial life to remove the carbon dioxide yet, so more and more of it is accumulating, trapping heat and making Earth hotter. With this new heat, the ice sheets are melting away. This volcanic action is still affecting us today. The lava spewing from the volcanoes eventually helped turn carbon into diamonds. In fact, most natural diamonds today can be traced back to this era. So take a moment to think about this cataclysmic event 2 billion years ago on your wedding day. But this isn't all that's happening. Over in Africa, another massive event is occurring. Nature's first nuclear reactor. Now, you're probably wondering how you could possibly get a nuclear reactor going on Earth. After all, don't you need a concentration of radioactive material? Well, yes you do. And this is what that pocket of Earth had. During its formation, Earth had accumulated bits of uranium from interstellar dust. This uranium was created by supernovas as stars died and exploded. Over hundreds of millions of years, microbial activity concentrated this uranium, and tectonic activity had it buried deep inside of Earth. 2 billion years ago, the right set of circumstances came together. A nuclear fission reaction began in the concentrated uranium. Uranium is naturally radioactive, so it decays over time. It splits to release neutrons. Like one domino hitting another, these neutrons in turn hit other uranium atoms which split, and this causes a chain reaction, creating this natural nuclear reactor. This natural process might have important lessons for humans today. Burning fossil fuels is making climate change worse, and the pressure is on to explore other sources of energy, like nuclear fission. But one of the challenges has always been how to store nuclear waste safely. It's possible that by studying this uranium mine, we could learn something useful. All these processes are working to warm up the Earth. The warming sun, greenhouse gases from volcanoes, and in this particular spot, Earth's very own nuclear reactor. As temperatures rise, water is becoming more prevalent than ice, and the landmass of Nuna is shrinking. One more important thing is happening right now. You can't see a lot of it without a microscope, but the 1% of microorganisms that made it through the Ice Age are wiggling their toes, metaphorically speaking, and starting to thrive. New life evolved through the oxygen-rich Ice Age. Microorganisms evolved that took in oxygen to burn food and released carbon dioxide in the process. The carbon dioxide released was then used by the cyanobacteria to produce more oxygen. This was happening at a microscopic level. Today, it happens with all kinds of different creatures. Now, humans and animals breathe in oxygen and exhale carbon dioxide. Plants take in carbon dioxide, photosynthesize, and release oxygen. So, the cyanobacteria was one of the original building blocks for all life today. But the oxygen didn't just power up microbes. During the long Ice Age, it began to form a protective layer in the upper atmosphere of the Earth, the ozone layer. This protected new life from ultraviolet radiation. Practically speaking, it expanded the real estate of Earth. Microbial life could now live on thin films of water protected from radiation and use the sun's energy to photosynthesize. You know what? I just remembered I packed a special microscope in the time machine. I know, sorry, we could have used it earlier. But you can use it to take a better look now at how cellular life is evolving. At this point in history, cells are changing to become more complex, with a distinct nucleus. This will allow the first plants to borrow traits from the cyanobacteria, which allows them to photosynthesize. So we can thank these microorganisms for the creation of all plant life we have today. Without photosynthesis, plants just wouldn't exist. Other creatures began to form during this time too. Scientists have unearthed fossils of multicellular creatures. These are sea creatures with soft, gelatinous bodies. They come in many different sizes, some as long as 17 centimeters long. At the time, they probably burrowed into the mud of rivers. These particular creatures survived while oxygen concentrations were high, but later disappeared, leaving no direct descendants. Rest in peace, little guys. Their complex multicellular life is the basic blueprint for all multicellular life today. Plants, humans, animals, fungi. Even the algae from this time didn't disappear completely. They're preserved in beautiful rocks called stromatolites, and if you're ever in the mood to see 2 billion-year-old rocks, pay a visit to the Belcher Islands in Hudson Bay, Canada. Geological and biological events from 2 billion years ago are the key to life on Earth today. The oxygen we breathe, chlorophyll in the plants we eat, the beginnings of our complex multicellular existence, not to mention the protective ozone layer. Who knows? Maybe the past holds the key to our future. Maybe cyanobacteria could gobble up carbon dioxide and even save us from the climate crisis we're in today. As you head back to your modern-day Earth, it makes you wonder, what will life look like 1 billion years in the future? Well, let's check out one of my favorite episodes we've done exploring this scenario. If you traveled 10,000 years into the future, what would planet Earth look like? Would most of its surface be covered in volcanoes? Or would it be frozen in ice? What if you traveled even further, to 1 million years in the future? Would all of the oceans have evaporated? Or would it have become one giant water world? Okay, now, what about 1 billion years? Would there be any humans left? Or would they have settled in other parts of the galaxy? This is What If, and here's what would happen if you traveled 1 billion years into the future. Let's face it, the chances of any humans being around to greet you when you arrive 1 billion years into the future are pretty low. Several key existential threats face the human race, and if we want to be around in 1 billion years, we'll need to endure them all. We've seen how much we've struggled to come together just to survive a global pandemic. So how do we have any chance of enduring the threats of climate change, overpopulation, global nuclear war, killer asteroids and comets, natural ice ages, and the sun getting a whole lot hotter? Well, let's take a look into the future and find out. Just under 10,000 years from now, we're going to run into a big problem called the Deca-millennium bug. In the year 10,000 AD, software encoding the AD calendar year won't encode dates with more than 4 decimals. Remember Y2K? Yeah, it's just like that, except hopefully we won't panic as much this time around. On the bright side, in 10,000 years, genetic differences and traits between humans will no longer be regional. Traits like skin and hair color will be evenly distributed around the world. Maybe that will help us all get along, finally. 20,000 years into the future, none of the current languages will be recognizable. Future languages will only contain 1% of the core vocabulary words of their present-day counterparts. 50,000 years from now will mark a new glacial period for the Earth, which will start a new ice age. Niagara Falls will have eroded into Lake Erie completely. And, interestingly, a full day on Earth will also increase by 1 second at this point in time. So much more time for activities. In 250,000 years, the Loihi volcano will rise above the water to form a new island in Hawaii. And in 500,000 years, it's likely that an asteroid with a diameter greater than 1 kilometer will hit Earth, unless we can prevent it. The resulting crater will be no less than 400 kilometers across. It will start fires all over the planet and make the air unbreathable. So there's something to look forward to. And in case that's not enough, in 1 million years, we'll likely have another supervolcano eruption, large enough to spew out 3,200 cubic kilometers of ash. It would produce enough lava to fill 75% of the Grand Canyon. This would be similar to the Toba eruption that almost wiped out humanity 70,000 years ago. Oh, and the nearby star Betelgeuse will have exploded into a supernova by this time, making it visible from Earth even during the daytime. In 2 million AD, humanity will have settlements throughout the solar system. This also means that if populations on different planets have remained separate, humans may have evolved into other species adapted to their specific world. In 10 million years, a huge part of Eastern Africa will break off, forming a new ocean basin. In 50 million years, Africa will collide with Eurasia, closing off the Mediterranean Sea, and a new mountain range will form between the two land masses. This mountain range may include a mountain taller than Mount Everest. Out in space, Mars will collide with its moon, resulting in it developing a ring system like Saturn's. In 60 million years, the Canadian and American Rockies will have eroded entirely. In 80 million years, all Hawaiian Islands will be below the water. In 100 million years, an asteroid similar to the one that killed the dinosaurs 66 million years ago will likely hit Earth, one that is 10 kilometers wide. In 250 million years, all of Earth's continents will be fused together like Pangea, except this time it will be called Pangea Ultima. But don't get too attached to it. Because in 400 to 500 million years, Pangea Ultima will separate again. In 500 to 600 million years, a gamma ray burst will likely occur within 6,500 light years from Earth. If it strikes Earth, it could damage the ozone layer and trigger a mass extinction. 600 million years from now, the Moon will be so far from Earth that total solar eclipses will no longer be possible. And the Sun's increasing luminosity will have raised temperatures on Earth so much that it could halt plate tectonics movement. In 800 million years, carbon dioxide levels will drop dramatically and photosynthesis will no longer be possible. Free oxygen and ozone will disappear from the atmosphere, and complex life on Earth will die. And finally, in 1 billion years, the Sun's luminosity will have increased by 10%, and the average temperature on Earth will be 47 degrees Celsius. Our atmosphere will feel like a damp greenhouse, and our oceans will evaporate, leaving just pockets of water at each of the poles. When you arrive here in your time machine, be mentally prepared to take in a planet Earth that looks nothing like the one you remember. The human race will be gone, hopefully living its best life on some other far-off planet. Because of the intense heat, lack of water, and lack of breathable air, Earth will be uninhabitable. So you probably shouldn't stay too long. Okay, with Earth in a less desirable position, let's jump even further ahead in time. A time where humanity has conquered the entire universe. Let's see what happens if we become a Type 7 civilization. In the future, humans may no longer have a need for physical forms. We'll be able to explore different multiverses and manipulate time itself. These are just a few of the perks of a Type 6 civilization. What would your day-to-day life be like? How far will technology have to advance? And would all this advancement really be worth it? This is What If, and here's what would happen if humanity became a Type 6 civilization. Okay, let's kickstart our climb up the ladder of civilization, otherwise known as the Kardashev scale. Named after the astrophysicist Nikolai Kardashev, this scale measures the advancement of a society based on its ability to harness different amounts of energy. Currently, today, we're a measly Type 0 civilization. And if we were to make the first leap on the scale up to a Type 1, we'd need to harness all the energy resources available to us on Earth. Going up to a Type 2, we'd extend our metaphorical extension cord all the way out to the sun. And that would mean much more than just collecting the solar power that reaches Earth. We'd be harnessing all the energy of the sun and the solar system. Now, at the third stage, Type 3, humanity would now have the ability to control all the energy available to us from the billions of stars and black holes in our galaxy. This might seem crazy enough, but we're just getting started. Once we become Type 4 and Type 5 civilizations, humanity would be able to control all the power available to us throughout the entire universe and beyond. And what comes next seems even more impossible to comprehend. Looking at what would happen if we became a Type 6 civilization requires you to fundamentally transform what you think you understand about the nature of reality. At this point, we wouldn't just be manipulating energy and matter, but
also the fabric of space and time. And we wouldn't just be controlling multiple universes, we would be able to create or destroy entire universes at will. You would have godlike powers at your fingertips. Time would no longer be something we'd think of as flowing in only one direction. Instead of looking at it like a river, it would now be a sea that we could jump in and explore freely. You could travel back in time to witness the birth of stars, the formation of the galaxies, and the very creation of the universe. And it would be as fast and simple as blinking your eyes. And if you could control time and create your own universes, then of course you could determine exactly what happens in them as well. So in your universal sandbox, there could be one world where you are the supreme leader, another with all kinds of animals that have never existed, and maybe one where money really does grow on trees. Not that money would mean anything to you. With this enormous and purely theoretical amount of power, what would it even mean to be human anymore? Well, first of all, you'd look pretty different. You wouldn't have much use for your body anymore, but with the technology of a Type 6 civilization, you could equip your body with all the most incredibly advanced artificial intelligence tools imaginable. But that's just the beginning. You might exist as pure energy and consciousness, without flesh and bone. You could take on whatever form you desire. You and every other human would truly be gods. However, being this advanced would bring up a handful of ethical dilemmas. For one, if you were omnipotent, you'd have to develop new social skills with all the other omnipotent beings of the universe. Keeping secrets would be pretty much impossible. And no doubt, as you navigated through multiple universes, you'd come across at least a couple of civilizations that would be much less advanced than ours. There would need to be some sort of protocol on how to engage with them in a humane way. Especially if you could create and destroy universes at will. This would be a great power that truly requires great responsibility. You'd be able to design new life forms from scratch and guide them through their evolution, just as our species once experienced. If you were to wipe those same species out in an instant, well, it would raise enormous moral questions. And there's probably one other burning question on your mind. If you were so powerful, what would be the purpose of your life? Well, that's one thing we'll just have to wait to find out when we reach this height on the civilization scale.
Imagine a dry desert with never-ending sand dunes transforming into a lush, green tropical paradise right in front of your eyes. This is what could happen if we terraformed the Sahara Desert. A project like this could completely alter the world. It could help solve global warming, but it could also destroy our oceans and make the planet even hotter. Terraforming the Sahara Desert would have a good side and a potentially terrible side. In this episode, we'll take a look at what the single biggest challenge would be during this mega project, and whether or not doing this could save or destroy the world. This is What If, and here's what would happen if we terraformed the Sahara Desert. So, what would our terraformed Sahara Desert look like? Well, there are two different ways this could play out, but one thing is for sure. Whatever we end up with would look very different than what we have today. The first option is replacing the vast desert with rows and rows of trees, but the Sahara Desert is about 9.8 trillion square meters. If you're having trouble understanding just how big that is, it's roughly the same landmass as the United States. So, how many trees are we talking here? Well, let's assume one tree would be planted for every 10 square meters. So if we look at the entire desert, that would mean 980 billion trees would need to be planted. How does this compare to the Amazon rainforest? Well, I'm sure that has way more trees than this desert, right? Well, if we follow through with this plan, the Sahara Desert would have more than twice as many trees as the Amazon. The rainforest only has a measly 400 billion trees. And the trees in the Sahara would be pretty specific varieties. If you're dreaming of pine forests or giant redwoods, forget it. We'd have to use trees that don't need a lot of water in order to thrive. Trees that can grow on just 500 millimeters of water per year. Okay, now let's fast forward a bit. If we transform the Sahara Desert even further, we would be creating a subtropical climate, adding vegetation that would help remove carbon from our atmosphere. Creating forested areas of the desert would be part of the plan too, but planting a full forest of 980 billion trees is unrealistic. TreeAid, an organization that works on planting trees in Africa, plants one tree every 19 seconds. Now, even if you supercharge that rate to one tree every second, it would still take 31,000 years to plant the full 980 billion trees we've calculated. I think we'll be living on Mars way before that. Anyway, a giant forest in the Sahara would do little to transform the lives of the people living there. About 2.5 million people live in the Sahara Desert today. Many are nomads traveling from one place to the other. The Sahara is also home to 100 species of reptiles, 70 species of mammals, and 90 species of birds. Mass afforestation would disrupt the way of life of these people and destroy these desert species. If there's going to be a transformation, these countries would be more likely to support one that also transforms the lives of their people and is consistent with their current lifestyle. So let's look at our second option. Instead of just one giant forest, we could have a bit more variety in the terraformed Sahara Desert. We could have some forests, but intersperse them with farms and grasslands. This would mean that people within these communities could help develop this new Sahara. They could participate in cultivating these farms, allowing for new economic opportunities. With this scenario, terraforming would involve planting native species that are more likely to withstand the changing climate. This would increase the genetic diversity and give this desert a better shot at thriving and turning into a forest. But this Sahara wouldn't just be a lush greenland for us to enjoy. This much greenery requires a ton of infrastructure to bring in one very important thing: water. How much water would we need in order to pull this off? Well, let's look at our first terraforming concept, the one that only involved trees. Scientists have estimated that this forest would need around 4.9 trillion cubic meters of water per year. For reference, that's more water than the entire globe uses in 365 days. So we would need to double the Earth's water consumption in order to provide for this Saharan forest. And where would all this water come from? Well, surprisingly enough, one of the sources of water could be right under the sandy desert soil. There are giant aquifers in Africa with huge groundwater reserves. Could we use this water to transform the desert into a subtropical haven? Well, we could, but it would dry up in about 30 years. This aquifer is also being used to support multiple countries' water needs, so if we tapped it just for this forest, that would mean that countries like Sudan, Libya, and Egypt could all be without water. There would have to be another solution. The ocean? Well, there are two problems with using ocean water. You know the first one, it's salty. That's why sailors complain. Water, water everywhere, but not a drop to drink. Then there's a second problem, getting the water to where it's needed. Addressing these issues could totally transform our initial plans. We'd have to build massive desalination plants that would get the salt out of the ocean water. So now reimagine that desert landscape with forests, developing farmlands and grasslands, but Near the ocean, it's now dotted with enormous desalination facilities. What you wouldn't be able to see would be the thick underground pipes transporting the water into the heart of the desert. To run desalination plants and pump the water, we would need a ton of energy, so we would need to install rows of solar panels in the desert that would harvest the sun's energy. This could provide electricity for all these new developments. If we were to install these desalination plants and use some water native to the Sahara Desert, we could make this work, but the price tag would be ridiculously high. Desalination technology has come a long way, but estimates put the energy costs of doing this at almost $2 billion per year. And then there's the cost of infrastructure, building it all out, maintaining it, running it, not to mention all the planting, solar panels, and whatever else we'd need to do to make this a reality. The bottom line is it will cost trillions of dollars to get this project started and maintain it. With this much cash required, paying for this would be a complete global effort. You'd need dozens of different wealthy countries in order to make this work. Maybe throw in a couple billionaires willing to donate for good measure as well. But let's assume we did get the money together to do this. Now, how would the plan unfold? This effort would be a complex project requiring cooperation and coordination across multiple countries in Africa. We'd also need the help of multiple aid organizations, engineering firms, land management experts, and more. It's safe to say this would be an all-hands-on-deck sort of effort. The economies of these countries and the lives of people all over the world would be transformed by this type of project. Even if the technology to build desalination plants or lay the underground pipes came from the West, a project of this scale would create a massive number of jobs to set up the infrastructure, plant the vegetation, and maintain the entire system. In addition, as the area developed, it would draw in tourists. Other professionals like doctors and researchers would also travel here for new opportunities to support and study the transformation, leading to more growth. For comparison, we can look at the Great Green Wall Initiative. This is a project working on building a green wall of trees across the southern border of the Sahara Desert. This aimed to create 10 million jobs, so a project aiming to terraform the entire Sahara Desert could easily have the potential to create millions and millions of jobs. Once we finally terraform the Sahara, what happens next? How does this play out decades into the future? Well, let's take a look and see. In order to find our answer, let's take a look back at the Great Green Wall. In 2007, the Green Wall concept came together with a goal of an 8,000 kilometer wall to be completed by 2030. About 250 million hectares of degraded land was to be restored in the Sahara. About 17 years later, only 44 million hectares have been restored. That's less than 20% of the goal. But this slow progress is mostly due to a lack of money. So let's assume money is no object, that the Western nations come together and pledge vast sums of money to terraform this desert. How quickly could we set up the infrastructure and get forests to grow and begin to cultivate farmlands? Well, when humans don't intervene and nature takes its course, a forest could develop over 600 to 1,000 years. If humans plant trees and then leave it up to nature, the time period for a forest is now estimated at around 100 years. This sounds way too long. I'm pretty impatient, so let's look for another solution. With lots of human intervention and even more money, we can make this happen a whole lot quicker. Let's take a look. 10 years. 10 years into this project, the focus would be on infrastructure. The world would work at warp speed, creating the desalination plants needed to make water. We'd also map out the locations for forests, farmland, and grassland. We'd also have to prepare the soil with any nutrients needed to support any native species. As this infrastructure began to get laid out, we'd probably begin planting, probably near the coastal areas. 20 years. In the second decade, you'd want to extend this piping further into other parts of the Sahara. The planting of trees and development of farmland and grasslands would continue, and as more and more vegetation is laid down, the soil will begin to transform. The vegetation will change the cycle of rainfall, and a transformation away from desert to more tropical may begin. Would this massive forestation project solve the problem of global warming? Would it remove all the carbon we needed from the atmosphere? Well, since trees help capture carbon, which humans produce a lot of, yeah, it would certainly help, but would that be enough? Some scientists have looked into scenarios where emissions continue to rise rapidly, and even a brand new giant forest might not be able to help keep up with our emissions. So, in theory, this forest could help, but that's only if we stopped emitting so much carbon dioxide into the atmosphere. 50 years. 50 years into this project, the Sahara could turn into a massive greenscape, but this wouldn't be all good news. There could be 3 spillover effects that create a serious problem for the planet. The first problem, an unexpected effect on global temperatures. While pulling carbon out of the atmosphere reduces the greenhouse effect and helps cool the Earth, forests and grasslands themselves could also change something. They could absorb the sun's energy more than the sandy desert does today, causing the Earth to get hotter. But the jury is still out on whether this would happen or not. There's evidence to suggest clouds tend to form more over forests, and clouds are great at reflecting the sun's heat, so maybe a green Sahara would be good after all. But there's another unexpected side effect when it comes to our terraformed Sahara, and it's something that affects parts of the world that are millions of kilometers away. The second spillover effect impacts ocean life. You might think of sand as these annoying grains of rock, the stuff that gets stuck in your shoes after being at the beach. But the sand in the Sahara has a very special purpose. Through sand and dust storms, these grains make their way to the Atlantic Ocean, and this sand contains valuable nutrients that feed life found in the water. It contains things like nitrogen, phosphorus, and iron. These are the nutrients that are essential to the ocean food chain. And if all this desert sand suddenly became a forest, then the essential part of that food chain would be gone. Huge amounts of ocean life could die out or go extinct. But the story of the Saharan sand doesn't end in the Atlantic. There's a third spillover effect. NASA satellites have revealed how this rich, mineral-carrying sand is carried by winds all the way to the Amazon rainforest. Some of these rock minerals are rich with phosphorus, and phosphorus is essential for plant growth. Approximately 22 million kilograms of phosphorus gets deposited into the rainforest every year from the Sahara. Binding up the sand would have a terrible consequence for the Amazon rainforest. 1/4 of all the carbon dioxide absorbed by land is taken in by the Amazon rainforest. Greening the Sahara would ultimately rob it of its nutrients and eventually leave it to die. Terraforming the Sahara Desert would be a big, ambitious project that could transform the lives of people who live there. While it would make a positive dent in absorbing emissions, it could have catastrophic global consequences. 66 million years ago, a giant asteroid struck Earth, wiping out the dinosaurs and 75% of the other animals on Earth. Devastating, yeah, but this was millions of years ago. What if this asteroid were to collide with us today? Is there any chance we could stop it? What parts of the world would be most impacted? And why might this end up being a good thing? This is What If, and here's what would happen if the dinosaur-killing asteroid struck in 2024. Okay, let's see what kind of asteroid we're dealing with here. Known as the Chicxulub impactor, this asteroid was as wide as 100 to 200 football fields. That's 10 to 20 kilometers wide. And now it's coming directly toward us. specifically the Yucatan Peninsula in Mexico. If you think you can run away from this thing, yeah, no chance. It's hurtling toward Earth at 20 kilometers per second. Suddenly, it crashes into the sea, killing everything in the immediate vicinity. But that's not all. A thermal pulse radiates out from the blast site, releasing the energy equivalent of 10 billion nuclear bombs. Cue an enormous shockwave of air that destroys everything within 1,500 kilometers. Plants and animals are shredded, forests burned to the ground. A magnitude 10 earthquake would crack the earth open. Quakes would radiate throughout the United States. Massive tsunamis would rise. Mexico City, Florida, and Texas would all feel the effects. I know Texas has talked about seceding, but I don't think this is what they had in mind. Now, although there will still be life on Earth, it might not last much longer. Plumes of dust and sulfur in the atmosphere block the sun. For the next 15 years, it's a cold, dark, awful winter. Only a few of us will make it out alive. But maybe the humans that do survive will be able to rebuild Earth. And funny enough, that massive asteroid that caused all the damage, well, it might hold the key to a stable new future. And luckily for us, it's not 66 million years ago. It's 2024, and we're Homo sapiens, creatures with really big brains and bright ideas. No offense to the T-Rex, but they definitely weren't getting Wordle in 2, and they definitely weren't tracking the sky for asteroids. But there's a team at NASA doing just that. And if we were able to spot an asteroid ahead of time, could we somehow steer it off course? Well, it's possible to deflect an asteroid from its path. Here's 5 different options we can explore. The first possibility is a kinetic impactor. This is the only deflection option scientists have tested so far. The idea behind it is to violently slam an object into the asteroid, pushing it off its path. NASA tested this technique in 2022 by slamming a spacecraft into Dimorphos. Dimorphos is the moon of a near-Earth asteroid, and thanks to the force of the collision, it's now going faster. So, in theory, we could use this option to move an asteroid off course. But there's a bit of a problem. The asteroid we're dealing with is way too big. In order to successfully knock it off course, we'd need multiple kinetic impactors. I'm not liking our chances with this one. Let's see what else we got. Okay, the second option for deflection is called a gravity tractor. Think of this like your dog pulling on its leash, taking you down a different path to smell something interesting. Minus the dog and the smell. Here, a spacecraft flies next to an asteroid, changing its path by the force of its gravity. Unfortunately, there's a big problem with this method. Well, for starters, it takes a really long time, and again, it only works on small asteroids, ones that are less than 500 meters in diameter. Yeah, this will be a no-go when it comes to the massive asteroid heading toward Earth. Okay, the third option is something known as an ion beam shepherd. But instead of herding goats, this shepherd is a spacecraft herding the asteroid out of our way. The spacecraft has an ion engine which generates an exhaust of accelerated xenon ions. These ions are super powerful charged particles, and the force of these charged particles deflects the asteroid. But probably not powerful enough to deflect a Chicxulub repeat. Okay, next up, space lasers. Now, if you're imagining zapping the entire asteroid with lasers so it vaporizes, no, that's not it. Unfortunately, it isn't as cool, but it can be effective. The laser is trained on the surface, creating plumes that push the asteroid away. And if we had enough lasers that were powerful enough, this might be a viable method. Finally, for a really big asteroid like the one we're dealing with here, and something's got to be done, there's always nukes. Now, this would be incredibly dangerous because there's always the possibility of fragments of the asteroid or other space debris falling on Earth. Not to mention, launching nukes in general is a super risky endeavor, but let's be real. An emergency like this probably justifies us unlocking the nuclear codes. Scientists tell us that sending a nuke that detonates next to an asteroid 2 months ahead of time could vaporize 99.9% of the asteroid's mass away from Earth. Sounds pretty good to me. Now, all of this only works if we spot the asteroid way ahead of time. If for some reason we don't, and an asteroid suddenly came out of nowhere, we'd have a mass evacuation. The evacuation zone would be determined based on the size, speed, and angle of the impending impact. Since it's hitting the Yucatan Peninsula, well, the US, Cuban, and Mexican governments would be busy evacuating people in Mexico, Cuba, and parts of the southern United States. The three governments would have to create alternative arrangements for food and shelter for hundreds of thousands of people, maybe more. Now, mass evacuation doesn't sound like a walk in the park, so is there any upside to having an asteroid land in our backyard? Well, yeah, there are amazing gifts the asteroid could bring us. A whole host of valuable minerals. Due to their highly inconvenient locations in deep space, like in the asteroid belt, these space rocks are extremely difficult to mine. But this would change if an asteroid landed on Earth. Just a single asteroid is estimated to contain a ridiculous amount of gold. 700 quintillion. That's enough zeros to give every person on Earth $93 billion. And there are other elements that we might be able to extract as well. Cobalt, platinum, nickel. In fact, the pressure with which the asteroid crashes can transform one element into a more valuable one. For instance, at a meteorite crash site in Australia, a rare mineral, rhyodite, was found. It was formed out of zircon as a result of the high pressure and temperature of the impact. And mining these elements from asteroids could free us from the human rights issues that have been part and parcel of traditional mining. Caliber mining follows ethical mining practices, but not every mining company does. In addition, mining asteroids would be more environmentally friendly, free of the danger of releasing toxins like lead and arsenic into our water. Today, large impact craters in South Africa and Canada are already being mined. They're rich sources of nickel and gold. The devastation from the crash of an asteroid would be horrific, but if it turns out it's unavoidable, that devastation may hold the clue to new resources and new growth. Welcome to the Permian period, an ancient time full of life, but also death. The Permian was home to the largest mass extinction event in Earth's history, even bigger than what wiped out the dinosaurs. Nearly all life was brought to an end. But how did this extinction event come about in the first place? And what kind of life did end up surviving? This is What If, and here's what would happen if you lived in the Permian period. The Permian period lasted almost 50 million years, from 299 to 252 million years ago. You can divide it into three parts: early, middle, and late. And we're going to walk you through all three of them. Let's start, obviously, in the early Permian. This period saw the birth of some of the earliest four-legged creatures. They're all extinct now, but they were the forefathers to dinosaurs and later mammals. They were massive predators that you definitely want to stay away from. On land, the apex predators were the synapsid. This species ruled the land before dinosaurs took their place. They're often referred to as mammal-like reptiles, and they look like a mix between a dog and a lizard. They also had incredibly thick skin, which retained a lot of moisture. This allowed them to thrive in the increasingly dry environment. The most famous synapsid, and one you would definitely not want to encounter, is the Dimetrodon. Over 3.5 meters long, this carnivorous predator had a large sail on its back. Since it was cold-blooded, it needed something to regulate its temperature. Maybe this sail-like appendage did the job. It helped the Dimetrodon heat up and cool down depending on the temperature. These beasts were also equipped with an incredibly scary mouthful of teeth that were all different sizes. Another animal you'll have to worry about? Gorgonopsians. These were carnivores with saber-toothed fangs. They remind me a lot of Siberian tigers. Some scientists have described them as the T-Rex of their time. They were frightening predators that could destroy anything in their path. And their favorite food? Dicynodonts. That name literally means 2 dog teeth. Thankfully, if you encountered one, you wouldn't need to be afraid because they might become your lunch. Yeah, these synapsids were herbivores, and they came in all different sizes. They could be small, like a pet dog, or as big as a cow. Dicynodonts looked like the love child of mammals, reptiles, and birds. They had the skull of a turtle, the beak of a bird, and even tusks to dig food out of the ground. Dicynodonts in the Permian era were cold-blooded, but during the Triassic period that followed, varieties evolved to become more like mammals, with features that helped keep them warm. Now, amazingly, these creatures survived the catastrophe that we'll get to later on, which is a good thing because otherwise humans wouldn't have evolved. We'll get back to what creatures you'd come across in the Permian in a bit, but for now, let's talk about where they lived. Okay, during this period, if you looked down on Earth from high up in space, you'd see that the land was made up of just one supercontinent. It was called Pangaea. It was formed by the collision of 2 large continents, Gondwana and Euramerica. The formation of this single large landmass had a massive impact on the climate. But before we get to that, let's look at how today's continents mapped into this supercontinent. Pangaea looked a bit like a giant crescent. The top curve of the crescent would later break apart to form Europe and Asia. The main body of the crescent contained North America, South America, and Africa. And the bottom, well, it would later separate to form India, Antarctica, and Australia. The crescent curved to contain what was called the Tethys Ocean. And the rest of Earth, well, it was all one giant body of water called the Panthalassic Ocean. Okay, so far so good. Yeah, you don't have the choice of 7 continents to live on, but you could set up camp anywhere on Pangaea. Maybe you'd enjoy a spot on the beach. But here's the important question. Are you gonna freeze to death? Or would you just bake? Well, this would depend on when you get there and where you land. At the beginning of the Permian, Earth was actually in an ice age. Hope you packed a parka. If you set foot on the southern region of Pangaea, you'd find tons of glaciers, or literally gigatons of glaciers. These could be found in what is now southern India, Australia, and Antarctica. Now, due to this giant landmass, the weather will be vastly different from what you're used to today. In our current world, the oceans do an amazing job at absorbing heat. They also warm up and cool down slowly, affecting the temperatures on land. But on this supercontinent, the interior land was far from water, so temperatures in this area are much more extreme. In the middle Permian, you'd enjoy a climate that's warmer, milder, and moist. The glaciers have now receded. Inland, Pangaea is arid, and according to the Pangaean mega monsoon theory, there were extreme seasonal fluctuations. You'd be hit with wet and dry periods throughout the year. With further increases in temperature, the late Permian would be very dry, with some alternating warm and cool periods. Now, what about the atmosphere? Was there enough oxygen for you to survive? Well, at the beginning of the Permian, oxygen concentration was actually pretty high, 30%. This is because of what had happened on Earth during the previous Carboniferous period. Forests had covered the Earth, creating an oxygen-rich atmosphere. Now, you might enjoy this extra boost of oxygen. You'd feel more energized and lively. Living in the mountains would be much more comfortable because the thinner air would now be offset by the higher oxygen concentration. But as good as oxygen is, you can't breathe it for too long at this concentration. Over time, you'd overdose and get oxygen toxicity. You could have difficulty breathing, and in severe cases, you might have a seizure and die. But high oxygen levels didn't last the whole time. There was a big drop toward the end. But before we get to that, you're probably wondering, what is there around here to eat? Well, as temperatures rose during the Permian, plant life began to take off. But unfortunately, there wouldn't be many options for you on the menu. In the early Permian, there were polar tundra regions, as well as tropical swamp forests. Now, as the climate became more dry, the swamp forests dried out, and water-loving plants shrank to become shrubs. So, unless you had the jaws and stomach of a cow, or 4 stomachs of a cow, eating these dry shrubs wouldn't have been too much fun to chomp on. And unfortunately, these shrubs were all shrub, no berry. There were no fruits at this time. They didn't really evolve till the Jurassic, so you'd probably be at risk of getting scurvy. But there was plenty of one thing: ferns. Ferns were the dominant plant life. Maybe you could eat some tender fern leaves and make some tea out of tree bark. It's no whopper value meal, but it'll do, I guess. Some of these plants would have been dangerous too. You wouldn't be accustomed to them, and they might cause some sort of deadly allergic reaction. But nasty plants weren't your only option for food. Why don't you try a nasty insect instead? The increased growth of plant life during this time provided a haven for insects. Bugs with sucking mouth parts made their debut during the Permian. You'd also see massive dragonflies roaming about. Maybe try to catch one of those. I wonder if they taste like chicken. You'd also notice that these insects are massive. In the early Permian, the large insects from the previous Carboniferous era were still around. By the middle Permian, these giant insects had disappeared. What was left were smaller insects that are still around today in some form. But forget these gross plants and insects. Where are the animals we could eat? Well, you wouldn't want to target the scary Dimetrodon or the Gorgonopsian that we met earlier. Some grilled herbivorous Dicynodont would be nice. It's no Popeye's Spicy Chicken Deluxe, but it just might hit the spot. Now, on the smaller side of creatures, there were the Varanopids. These were small lizard-like creatures that mainly dined on insects. Another super important group during the Permian was the Sauropsids. These were basically reptiles. During the Permian period, when synapsids dominated, the Sauropsids remained small and lizard-like, but they'd make a fiery comeback later on. I don't know about you, but these animals are either looking scary or unappetizing, and I'm not really in the mood to eat a cross between a lizard and a dog. Can you catch some fish? Maybe a fillet of fish? Permian seas were full of bony fish, which had 2 features: fan-shaped fins and thick scales. There were also creatures with coiled spiral shells called ammonoids that lived in the water. Again, it's no ultimate endless shrimp, but a seafood diet might be your best bet. Now, if you go for a dip, watch out. You'll want to steer clear of the scary Gyaesia geniae, a salamander-like creature with deadly fangs and a 2-foot-long skull. This creature was way bigger than you. It was 2.5 meters long. Scientists describe its head as being like a toilet seat, which opened up to suck in its prey. The good news? It was sluggish, so if you're a fast swimmer, maybe you can escape it. But not everything thrived during this time. As you reach the late Permian, you'll notice things changing. Creatures all around the planet are going extinct in what's known as the Great Dying. This was Earth's biggest mass extinction event. 90% of marine life and 70% of all animal and plant life died out. Now, scientists still aren't completely sure what caused this mass extinction, but there are several theories. One of the leading theories is that a series of natural disasters is what got the whole thing going. Volcanoes. Toward the end of the Permian period, there were massive volcanic eruptions in what's now Siberia. And not just for a few years or decades, for about 600,000 years. Huge flows of lava flooded the region, but It wasn't the lava that caused the extinction. It was the volcanic gases that were being spewed into the air. This caused an increased concentration of sulfur dioxide in Earth's atmosphere. What happened next? Acid rain. Volcanic ash was also thrown up in the sky, blocking the sun, making it dark out, also causing the temperature to fall. As a result, plants found it harder to photosynthesize and the food chain was disrupted. The extinction of plant life, then herbivores, and then carnivores followed. It was like a set of dominoes falling. But it wasn't just the food chain. It was literally becoming harder to breathe because the impact to plants also had major effects on the atmosphere. With the disruption to photosynthesis, carbon dioxide increased while oxygen levels plummeted to 16%. Animals that had evolved in a more oxygen-rich atmosphere weren't ready for this drop in oxygen and then died off. If you were there, it would be like trying to breathe at the top of a giant mountain today. Now, as this was happening, animals living at higher altitudes suddenly found the oxygen too thin for their requirements, so they probably moved to lower altitudes and had to compete with other species. Some scientists believe that this is what drove land-based extinctions. Oxygen levels were so low that animals had to remain where the air was most dense, at sea level. Even the slightest climb to a higher altitude would have them gasping for breath. And the rising carbon dioxide also created a greenhouse effect, causing temperatures to rise. This made the oceans warmer as well, which killed a ton of marine life. The rising temperature plus the reduced oxygen equaled a horrible world for all life on Earth, making it nearly impossible to survive. But there's a third theory. Initially, scientists estimated that the Great Dying took place over millions of years, but more recent archaeological evidence indicates that it happened much faster, maybe between 8,000 and 100,000 years. Could something else have happened that caused an abrupt end to these creatures? Yeah, some scientists think there's another culprit, an asteroid. In addition to all these erupting volcanoes, scientists have also found evidence of an asteroid collision. This asteroid may have been 6 to 12 kilometers wide. That's bigger than Mount Everest. So maybe it's a mix of all of them. The volcanic eruptions, the atmospheric effects, and then wham! A massive asteroid as the final nail in the coffin. You combine all three of these events and you've got yourself the Earth's largest mass extinction. But not all creatures died off. Some of the lucky ones managed to survive. The Dicynodonts later evolved into rodent-like creatures. They lived side by side with the dinosaurs. Sure, they weren't the top of the food chain, but it beats going extinct. They even outlasted the dinosaurs, evolving into present-day mammals. Small sharks migrated to the depths of the ocean, avoiding the acidic coastal waters, and they're still around today. The sauropsid reptiles also survived. Small lizards had a better chance of surviving compared to the big synapsids. Being cold-blooded and sluggish were excellent survival traits. In the coming Triassic and Jurassic periods, they evolved into mighty dinosaurs. It was once assumed that most trees went extinct during the Great Dying too, but scientists continue to find plant species that survived that time. Life, whether it's microorganisms, plants, or animals, is resilient and it always finds a way.
Over 300 million years ago, before the age of giant dinosaurs, Earth was covered with giant insects. Imagine a world where dragonflies are the size of crows and millipedes are as long as cars. Welcome to the Carboniferous period. Why were insects so enormous during this time? What did oxygen have to do with it? And why did these insects go extinct? This is What If, and here's what the Earth looked like in the age of giant insects.
The Carboniferous period was one of the most transformational periods in the history of Earth. The planet's land masses were beginning to form the supercontinent of Pangaea. Extensive swamps and warm, humid forests dominated the landscape. And giant insects weren't the only huge creatures roaming the planet. There was also a vast array of marine life, like early forms of sharks and a giant amphibian that would reach up to 6 feet long. Now, enough talking. Let's travel back in time, 300 million years ago, and dive into the Carboniferous Age. Now, the first thing you'd probably notice would be the giant insect-like creatures. One of the most iconic was the Meganeura. This insect resembled a modern-day dragonfly, except with a major twist. It had a wingspan of up to 75 centimeters. Yeah, scarier than that though, it was carnivorous, hunting down other insects and small amphibians. Hopefully it doesn't come for you. So that thing is in the sky, but on land, you'll have the Arthropleura. This millipede-like creature could grow up to 2.5 meters long. Luckily, it wouldn't go after you. It preferred munching on decomposing vegetation. Hey, before we talk more about these giant insects, there's another giant issue we need to worry about, and that's our planet's ecosystems and how important it is to help them. Stick around till the end of this video to check out an inspiring project from the folks over at Planet Wild. Another creepy-looking insect was the Pulmonoscorpius. This was a giant scorpion that mostly roamed the swampier areas of Earth. They could grow 70 centimeters long. There were also giant cockroaches that grew to 10 centimeters and mayflies with 45 centimeter wingspans. So it's safe to say that you'd have a lot to watch out for when you're wandering around in this period, but the question is, how did these insects get so big anyway? Well, you may have noticed as you've been hanging around in the Carboniferous Age, you feel a lot more energetic and alert. Maybe you've had an easier time running around. This has to do with the oxygen levels in your current world. Research has estimated that the atmospheric oxygen levels were as high as 35% during this period. Compare that to the 21% we breathe today. Oxygen was one of the key factors in the gigantism found in insects at the time. But why would this make them so giant? Insects breathe differently from other creatures. Insects don't have a circulatory system to transport oxygen. Instead, it gets delivered directly to their tissues through a network of tiny tubes called the trachea. And the more oxygen in the atmosphere, the bigger these insects are. But there might be more reasons why the insects grew to this size. Another theory suggests that the insects were forced to grow so large due to oxygen toxicity. Yeah, as amazing as oxygen is, you can have too much of a good thing. Too much oxygen in your body can create what's known as free radicals. These are unstable molecules that can damage your cells and even damage your DNA. In the case of our insects, they were forced to grow this big. Otherwise, they'd suffer oxygen toxicity. Growing larger would slow down the rate of oxygen absorption, making it harder to suffer from too much oxygen. And the same could happen to you. The longer you hang out in this period, the higher oxygen levels will cause you to experience nausea, respiratory issues, and even some effects on your nervous system. Now, insects were arguably the stars of this age, but they weren't the only things to experience massive change during the Carboniferous period. This time was known as the Coal Age. That's because of the extensive coal beds that formed after ancient forests decayed. These coal beds are one of our main sources of energy. We're still using them today. And a lot of the fruits and veggies you find in the grocery store may be descendants of plants from over 300 million years ago. The Carboniferous period saw the evolution of the first seed-bearing plants.
creating more diverse ecosystems than we'd ever seen before. Wait, what's that over there? Kinda looks like a dinosaur. Oh, hey little guy. Turns out this wasn't a dino, just one of the first reptiles to ever appear. But if you stick around a couple of million more years, we'll enter the Mesozoic era, which was known as the Age of Dinosaurs. Speaking of change, the atmosphere was another part of Earth that evolved during this period. Earth had a lush, greenhouse-like climate when you first arrived, warm and humid temperatures to support the swampy forests we've been mucking about. But as the period progressed over millions of years, the climate transitioned to what's known as an icehouse Earth state. The temperature would get significantly lower and ice sheets would begin to form, mainly in the southern hemisphere. But why did this happen? Well, as we've been exploring this crazy period, Earth's land masses have been slowly coming together to form a supercontinent known as Pangaea. And when land masses this big start to move, it can seriously affect ocean currents, wind patterns, and global climate. Now, the rainforests have collapsed, which has led to a decline in the fauna and vegetation that were previously booming. And with the rainforests in decline, well, that means oxygen levels are being reduced. Before you know it, our massive insects start dying and going extinct. Without the higher levels of oxygen available to support their size, well, these giant insects can't survive. The lower oxygen levels and a drier climate have created a habitat better suited for smaller insects. Also happening at this point, early reptiles are starting to take over, making the landscape way more difficult for the insects. We often think of dinosaurs as some of the most terrifying creatures that have ever existed. But what if I told you that there were some ancient creatures that were even more terrifying than dinosaurs? Ones with dagger-like teeth, massive horns, and gigantic sizes that would put T-Rex to shame. There were even some insects that were as big as you. Let's travel through time as we take a look at creatures scarier and more dangerous than dinosaurs. Megalodons. Ready to come face to face with one of the scariest aquatic predators of all time? Meet the Megalodon. The name of this prehistoric shark literally means big tooth, so you can count on the fact that these were some of the most terrifying animals ever to exist, especially during their time on Earth, between 3.6 to 23 million years ago. Megalodons were the largest sharks and one of the biggest fish ever, measuring a staggering 18 meters long and weighing over 70 tons. These sea creatures were mythologically gigantic and dangerous. They had massive jaws that could swallow you and a friend whole at the same time, even without clamping down on you with one of their many massive teeth that were bigger than dinner plates and perfectly designed to tear through your flesh with ease. Megalodons ate whales, dolphins, and possibly other sharks. And if we put them up against the scariest dinosaurs of all time, they'd certainly be a contender for the most apex of all apex predators. Woolly mammoths. Okay, let's move on to a beast that our earliest human ancestors used to encounter thundering through frozen landscapes. Woolly mammoths. These colossal creatures were a testament to nature's ability to adapt to and thrive in even the harshest of living conditions. They roamed the Earth during the Ice Age from about 400,000 to 4,000 years ago. And then they went extinct. If they hadn't, who knows if humans would have gone on to become the dominant species we are today. Woolly mammoths weighed between 6 and 8 tons and stood at the imposing height of nearly 4 meters. It just so happens that they had gigantic curved tusks that were also nearly 4 meters long. But while their absolutely intimidating size might make them as fiercely scary as the dinosaurs, These fuzzy giants were herbivores. Lucky for us, that means they wouldn't need to hunt us down for dinner. Saber-toothed tigers. This brings us to one of the most formidable predators of the Pleistocene epoch, maybe even of all time, the saber-toothed tiger. These prehistoric cats stalked the land like silent assassins between 10,000 and 2.5 million years ago. They hunted everything from mammoths to mastodons. And yes, it's possible that an ancient relative of yours might have had a close encounter with one of the beasts. Saber-tooths weren't your average house cat either. They could be as long as 2 meters from head to toe and weigh up to 300 kilograms. Plus, as the name suggests, they had 2 massive and sharp canine teeth that resembled long, curved swords. These made them truly fearsome predators. They would ambush their prey and take them out with bite after fatal bite. Not that I'd want to be anywhere near this battleground, but these are definitely animals that could take on even the most dangerous dinos, like velociraptors. Early primates. Okay, this one might not send the same shiver down your spine, but if you look further back into our own gene pool, there are some intimidating specimens. Like this ancestor of ours. Look no further than the early primate known as Dinopithecus. These baboon-like primates lived between 500,000 to 2.5 million years ago. And even though they aren't huge by today's standards, at around 50 kilograms, they were one of the largest primates of the time. And considering that they would have had to compete with the previous mentioned beasts and even early humans, there's no doubt that these monkeys knew how to fend off other large predators. Elasmotherium. This next ancient animal might have the most beautiful and least scary sounding name of them all. It was known as the Siberian unicorn. But don't be fooled, they were not rare magical horses. Actually, they were an ancestor to the rhinoceros. And you better believe that they were big and had one very large horn protruding from their head. They were believed to have weighed around 4.5 tons, but that didn't make them slow by any stretch. They had long legs that allowed them to run across open grasslands at stunning speeds. And while there isn't any evidence of one in our fossil records, it's possible that their mythologized unicorn horns measured up to 2 meters in length. Glyptodon. From here on out, some of the animals from the past could seem a little weird. And in terms of a scary weirdo that might be able to give a dinosaur a run for its money, check out the armored mammal known as the Glyptodon. These were basically prehistoric armadillos, which, to be honest, makes them sound kinda cute. Except they weren't that. Covered in a bony, armored shell, Glyptodons were up to 3 meters in length and weighed over a ton. Their shell was an excellent protective shield from predators, but that's not all they had going for them. Their tails were equipped with a spiky club-like end that was a powerful weapon against anyone who dared step in their way. If an ankylosaurus tried to mess with this beast, well, yeah, good luck. Glypto would club him right in the ankles. Giant cockroaches. In today's world, cockroaches are seen as pests, but also as a symbol of how life can survive even in the grossest, least hospitable conditions. Well, their prehistoric ancestors took resilience to an entirely new level. Approximately 359 to 299 million years ago, these critters were some of Earth's earliest inhabitants. And okay, compared to some of the other creatures on this list, they weren't huge, but at lengths of up to 9 centimeters, they were large for their time and bigger than any roach you'd want to find in your kitchen. And while they may not stand much of a chance against dinosaur predators, they had armored exoskeletons that would have done a pretty good job protecting them. Yeah, good luck calling an exterminator on these bad boys. Pulmonoscorpius. Imagine a scorpion. Okay, you're already running away screaming, but brace yourself for something even worse. A scorpion with a tail that's bigger than you. Yeah, that's the nightmare reality of the Pulmonoscorpius. Using this gigantic tail, they could deliver a deadly venomous sting. Not to mention they could attack and grab enemies with their imposing pincers. With most dinosaurs, you need to worry about confronting a towering beast with massive teeth, but with this giant scorpion, you need to worry about all that and the potential that they could poison you. Yikes! Any creature that coexisted with them about 300 million years ago would have been best to steer clear of these killer scorpions. Okay, these are a lot of terrifying creatures, but would they have actually stood a chance against some of the most fearsome dinosaurs? Which ones were those again? Well, that's a story for another What If.
Underneath Antarctica's ice, there's a deep, dark secret. Today, we're going to melt all that ice to find out how it would transform Earth. What mysteries lie buried deep under its thick, frozen surface? As the ice melts and sea levels rise, what would happen to our coastal cities? And why might this lead to some unexpected diseases? This is What If, and here's what would happen if all Antarctica's ice suddenly melted. Welcome to Antarctica, the continent that encircles the South Pole. It's 40% bigger than Europe and full of ice. Here you'll find seals, whales, penguins, and the odd scientists doing some research. And on this continent, you'll find an ice chunk the size of Florida. Welcome to the 120-kilometer wide Thwaites Glacier. Its more scary nickname is the Doomsday Glacier. When it melts, there will be a catastrophic rise in sea levels all over the world. Now, this Doomsday Glacier is melting incredibly fast. It sheds 50 billion tons of ice into the ocean every year.